Elon Musk has just confirmed that Optimus Gen 3 will feature a completely new design, significantly different from the previous generation. This is not merely an upgrade, it's a full redesign aimed at turning the robot into a truly commercial product. Every detail from the skeletal frame to the sensors will be refined. Tesla is preparing to bring Optimus into everyday life and mass production. So, what makes the new Gen 3 design so different and important? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What is the most anticipated design change in Gen 3? So many improvements to come in the next design of Optimus. Tesla is preparing to enter an entirely new stage of development for its humanoid robot, Optimus, with the Gen 3 design expected to bring major changes in structure, features, and large-scale production capabilities. The improvements already evident in Optimus Gen 2, from reduced weight and increased walking speed to an upgraded hand with 22 degrees of freedom, form the foundation for what Tesla is aiming to achieve in the next generation. Gen 3 will not simply be an upgraded version but a major leap in design aimed at bringing humanoid robots into real-world scenarios and enabling mass production at optimized cost. According to Elon Musk, Optimus Gen 3 will feature significant upgrades in overall design to improve operational efficiency and scalability. These changes are not just intended to make the robot faster and smarter, but also to standardize its structure for easy mass production, an essential requirement for rolling out hundreds of thousands of units annually, with a production target of over 100,000 Optimus units next year. Tesla needs a modular, highly integrated design that can be assembled by other robots on automated production lines. Therefore, Gen 3 will be heavily refined for manufacturability, similar to how Tesla simplified electric vehicle design to accommodate gigapress production for car bodies. The core of the Gen 3 design will focus on weight optimization, flexibility, and autonomy. In Generation 2, Tesla managed to reduce about 22 pounds compared to the first generation, significantly improving speed and agility. Gen 3 will likely be even lighter, built with advanced materials like ultralight aluminum alloys or carbon composites to ensure durability and optimal performance. The actuator and sensor systems will also be further compacted and more deeply integrated into the robot's skeleton, both to reduce costs and to improve motion precision. In addition, the hand design, already a major highlight in Gen 2 with its 22 degrees of freedom, will continue to be improved to handle more delicate tasks such as welding, assembling electronic circuits, or operating in tight spaces. Musk has previously emphasized that the hand of Optimus will be one of the most crucial components in making the robot truly useful in real-world environments, such as factories, retail spaces, and even homes. Notably, Gen 3 will feature even deeper integration with Tesla's central AI system, using human video-based learning to dramatically shorten training time. Tesla's shift from remote-controlled operation to video-based training offers a significant advantage, allowing each robot to learn new tasks much faster. This demands that Gen 3's design be capable of fast image and sensor data processing, along with real-time feedback mechanisms for each action, from the smallest gestures like pressing a microwave button to complex movements like yoga poses or bending down to pick up an object. Beyond the technical aspects, Gen 3's design will also prioritize aesthetics and user-friendliness. For robots to be accepted in everyday life, they need to appear approachable, non-threatening, and easy to interact with. This means Tesla will have to adjust both the robot's physical appearance and its body language to make it feel more natural and socially acceptable. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. What sets the Gen 3 hand design apart from previous versions? The hand is arguably the most complex and symbolic part of any humanoid robot, and with Optimus Gen 3, Tesla has completely re-engineered this crucial component to deliver a level of dexterity, precision, and adaptability that far surpasses earlier versions. Unlike the simplistic, rigid hands of Generation 1 and Generation 2, which were limited to basic gripping, the new Gen 3 hand features a highly advanced structure that allows each finger to move independently through multiple joints. This configuration enables the robot to replicate human hand movements with remarkable accuracy, from picking up tiny objects like pins to handling delicate items such as eggs or glassware. The fingers bend naturally at knuckles and joints, closely mimicking human tendons and muscle structure, making Optimus capable of performing fine motor tasks with high reliability. One of the most groundbreaking advancements is the integration of tactile sensors embedded within each finger. These sensors give the robot the ability to feel texture, pressure, and contact, allowing it to adjust its grip strength dynamically based on the object's material, weight, and fragility. This real-time sensory feedback, combined with force feedback mechanisms, prevents accidental damage and ensures safe handling. Whether folding clothes, sorting parts, or assisting an elderly person, the Gen 3 hand intuitively knows how much pressure to apply, something previous robotic systems struggled to achieve without complex external inputs. Tesla's design also emphasizes durability and maintenance efficiency. Each component of the hand is modular, meaning fingers or joints can be replaced individually without dismantling the entire system. This modular approach supports scalable manufacturing and lowers repair costs, a vital factor for widespread commercial and household deployment. The materials used are lightweight yet durable, likely a combination of carbon-reinforced polymers and aerospace-grade aluminum, ensuring both speed and resilience. Moreover, the hand is built to operate continuously without overheating, supported by a passive cooling system optimized for extended factory use or home tasks. In real-world use, these advanced hands have already proven their value. Tesla has tested Optimus Gen 3 in its own factories, where the robot performs tasks like picking up components, tightening screws, and manipulating wiring, all of which demand far more finesse than simple strength. In the home, this unlocks an entirely new range of possibilities: cooking, making the bed, helping people with limited mobility, or even assisting in medical therapy. With such fine control and awareness, Optimus is no longer just a functional tool. It's a potential partner in both work and life. Why is Tesla redesigning the Gen 3 bot instead of keeping the Gen 2 design? Tesla's decision to fundamentally redesign its Optimus humanoid robot for Generation 3, rather than building incrementally upon the Gen 2 framework, signals a bold transition in the company's strategy. From prototyping for internal validation to engineering a product ready for deployment at scale. This shift is not merely about cosmetic or minor performance upgrades. It's a redefinition of what the robot must be in order to succeed in the real world. Gen 2, while a significant milestone, was limited by constraints that no longer align with Tesla's ambition to manufacture hundreds of thousands of units per year and deploy them across varied environments. The Gen 2 robot served as a research platform, primarily intended for internal testing and proof-of-concept demonstrations. It allowed Tesla to explore key mechanical principles: bipedal locomotion, motor control, balance, and basic task execution. However, Gen 2's design was never optimized for practical long-term deployment. It carried many elements that were ideal for development agility, but inefficient for durability, cost, or manufacturability. These include excessive wiring, non-standardized actuators, exposed components, and materials not suitable for long-term use. If Tesla had kept the same architecture in Gen 3, it would have severely limited the robot's potential in terms of efficiency, production cost, safety, and ease of repair. Another driving force behind the redesign is the need for purpose-built architecture to support Tesla's rapidly evolving software stack and AI infrastructure. As Tesla leans into neural network training using video footage of human activity, the physical form of the robot must adapt accordingly. This isn't just a question of flexibility or joint count. It's about spatial harmony between AI perception and mechanical capability. Generation 3 must allow for more fluid, reactive motion in response to AI inference. That means re-engineering limb lengths, joint placements, weight distribution, and sensor integration. For instance, the camera positions on Gen 2 may have worked for static perception, but Gen 3 needs to optimize field of view, depth estimation, and proprioception during motion, all of which demand structural changes to the head, neck, and torso. Thermal management and energy efficiency are also key motivators for the redesign. Gen 2, like many early prototypes, was not optimized for passive or active cooling under continuous load. It could perform brief, impressive tasks like folding laundry or performing squats, but sustained activity would lead to heat buildup and component degradation. For Generation 3, Tesla is pursuing a design that enables 6 to 8 hours of continuous operation, aligning with real-world use cases such as warehouse assistance, household chores, or light-duty factory work. This necessitates a full rethink of internal component layout, the use of lighter structural materials, and more efficient distribution of onboard computing systems. Furthermore, the durability and safety requirements for Gen 3 are vastly different. Tesla plans to deploy Optimus in uncontrolled dynamic environments, including factories, offices, and homes, where the robot will be in constant proximity to people, furniture, tools, and unpredictable obstacles. Generation 2 was never tested for high-impact resilience, dust resistance, or fluid exposure. Gen 3 must therefore incorporate robust chassis enclosures, redundant fail-safes, and improved collision detection. A more compact and modular internal structure is also required to simplify maintenance and allow part replacement without disassembling large sections of the robot. These are not adjustments that can be grafted onto an existing design. They require a foundational rebuild. Tesla's experience with automotive manufacturing is another key influence. The company has repeatedly emphasized the advantages of vertically integrated design, from gigacasting vehicle bodies to optimizing wire harness layouts. In Genesis 3, this mindset is being extended to robotics. Fewer parts, less wiring, more shared modules, and a unified architecture that allows Tesla's automated production lines to build and test robots as easily as they build cars. This transition demands not just mechanical simplification, but also software-hardware unification. Generation 2 had legacy elements from disparate suppliers and test phase engineering. Gen 3, by contrast, will be natively Tesla-built, from motor to chip, using a production-oriented design language. Beyond technical motivations, the redesign also reflects an evolution in product vision. Gen 2 was never intended as a commercial product. It was a platform to demonstrate that Tesla could build a humanoid robot that walks and performs tasks. But Gen 3 must go far beyond that. It needs to serve real customers, deliver ROI for businesses, and meet consumer expectations for safety, reliability, and ease of use. For example, humans expect robots to interact with objects naturally, walk smoothly across various surfaces, and operate in tight spaces, all of which require careful rebalancing of limb proportions, control algorithms, and even the tactile materials used in exterior components. Generation 2 fell short in these areas due to its utilitarian, lab-focused nature. Lastly, Gen 3's redesign allows Tesla to implement a forward-compatible platform, one that can support future software upgrades, tool attachments, and even modular add-ons for specific industries. Whether it's a gripper for logistics, a vision system for inspection, or a voice interface for domestic tasks, Gen 3 must be ready to evolve. A rigid Gen 2-derived design would have limited this adaptability, forcing future versions to compromise or rework key subsystems. Starting fresh with Generation 3 ensures the bot's platform is flexible enough to accommodate years of iterative upgrades, 3 humanoid robots, 3 different approaches to handling household chores. But if faced with over 150 repeated tasks every day, which robot can maintain consistent performance? Durability isn't about appearance. It's about the ability to operate through thousands of task cycles without failing. Tesla, 1X or Unitree, who is truly the most reliable helper in your kitchen? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. Who's truly the top home assistant robot? One of the biggest differences between Tesla Optimus and its current competitors lies in its ability to learn and improve performance through artificial intelligence. Tesla Optimus is not just a robot that can repeat actions, but a constantly evolving system that learns from its environment and its users. This is made possible because Optimus is trained on the same AI platform as Tesla's full self-driving FSD system, which collects more than 500 million miles of real-world driving data every day from Tesla vehicles worldwide. As a result, Optimus continuously updates its ability to recognize environments, interpret behavior, and respond to unexpected situations via the network, whereas both 1X Neo Gamma and Unitree G1 Pro still rely primarily on traditional training models and simulated data. Tesla has also equipped Optimus with remote software update capability, a feature already proven effective across millions of Tesla vehicles. This means that if one Optimus robot learns how to fold towels more efficiently or wash dishes faster in a particular household, that knowledge can be instantly shared with all Optimus units globally through a shared neural network. Meanwhile, 1X Neo Gamma, despite claiming to integrate safe AI and private data, has not disclosed any global learning model. Unitree G1 Pro still relies on manual updates and lacks a mutual learning mechanism among robots, which significantly slows down its rate of improvement. At the hardware level, Tesla enjoys a major advantage by developing its in-house FSD chip, capable of 144 trillion operations per second, far exceeding the performance of commercial chips like the Jetson Xavier NX or Orin used in G1 Pro and Neo Gamma. With this processing power, Optimus can recognize images, sounds, and make real-time decisions on-device without needing to send data to the cloud, ensuring faster response times and greater privacy protection. On the other hand, Unitree G1 Pro is limited by commercial-grade processors that may struggle with multitasking scenarios like walking while observing objects or responding to voice commands. 1X Neo Gamma, while equipped with safe and robust hardware, lacks the flexibility and expandability seen in Optimus. Another critical factor is personalization. Tesla states that Optimus will learn each household's daily routines within just a few days, remembering object locations, activity schedules, and individual user preferences. This allows Optimus to automatically perform tasks such as cleaning the floor, reminding schedules, or fetching items correctly without human input. In contrast, Unitree G1 Pro mostly operates via manual commands or pre-configured settings, limiting its adaptability in complex home environments. 1X Neo Gamma can recognize faces and voices, but has yet to demonstrate the ability to remember repeated behaviors and optimize for them as Optimus does. Tesla also stands out by integrating Optimus into its broader smart ecosystem. Optimus is not an isolated product, but an extension of Tesla's vehicle network, Powerwall battery systems, smart home cameras, and its global AI training infrastructure. This provides massive advantages in data synchronization, device coordination, and leveraging daily data streams for continuous robot improvement. By contrast, 1X and Unitree are still operating as standalone products, with no connections to a larger AI ecosystem, a critical factor when considering scalability and long-term usability. In terms of development speed, Tesla has made striking progress with Optimus. In just 2 years, the company advanced from a basic Gen 1 prototype with unstable movements to Gen 3, capable of walking smoothly, folding clothes, watering plants, lifting objects, and performing over 150 basic daily activities. Meanwhile, 1X Neo Gamma is still in the process of testing smooth walking and limited interaction in controlled environments. Unitree G1 Pro, though already commercialized, remains constrained by a fixed set of pre-programmed tasks and lacks any autonomous learning capability like that of Optimus. In summary, when evaluating the full value chain, from hardware and software to AI intelligence, learning capability, and ecosystem integration, Tesla Optimus stands out as the pioneering humanoid robot for household service. Optimus's advantage lies not only in being able to do tasks, but in its ability to keep getting better without requiring hardware changes. While 1X Neo Gamma is more suited for safe office interactions, and Unitree G1 Pro targets affordability and research, only Optimus combines intelligence, autonomy, and adaptability to become a true assistant for everyday families in the near future. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. Which robot is the most durable and energy efficient for your home? When considering bringing a humanoid robot into your living space, the criteria of durability and energy efficiency are not just advantages, they're essential. A household assistant robot cannot simply perform well during a short demo or a promotional video. It needs to operate every day for many continuous hours without causing concerns about maintenance, wear and tear, or electricity bills. Among the three prominent names today, Tesla Optimus, 1X Neo Gamma, and Unitree G1 Pro, only Optimus truly shows signs of being ready to take on that responsibility. Tesla Optimus is designed from the ground up to work continuously for 6 to 8 hours on a single charge. According to information shared by Elon Musk, Optimus uses a battery of around 2.3 kilowatt hours, which translates to a power consumption of roughly 300 to 400 watts per hour during regular activity. For comparison, this is equivalent to running a small vacuum cleaner or a rice cooker. This is particularly impressive considering the range of tasks Optimus can handle, from folding clothes and carrying objects to mopping floors, opening doors, and navigating between rooms. That level of energy use demonstrates high efficiency, minimal waste, and full practicality for daily use without significantly impacting household expenses. In contrast, 1X Neo Gamma, though sleek in appearance with smooth joint movements, leans more towards social interaction and office environments. Weighing around 85 kilograms and standing 1.65 meters tall, Neo boasts advanced electronics but has yet to disclose any data about its ability to perform household tasks continuously. Additionally, its larger size and complex mechanical design make it difficult for Neo to match the energy efficiency of Optimus, which benefits from Tesla's deep experience in electric vehicle manufacturing. On the opposite end of the spectrum is the Unitree G1 Pro, small, fast, and quite agile. However, long-term operation is a clear weakness for the G1 Pro. Its battery is only around 900 watt-hours, providing less than 2 hours of continuous operation under ideal conditions. More importantly, it lacks a passive cooling system like the one in Optimus, making it prone to overheating during heavy tasks or extended use. This makes the G1 more suitable for demonstrations or very short tasks, but not as a true robotic housekeeper working through an entire morning in your home. Another key factor is the long-term durability of components. Tesla Optimus uses many parts shared with Tesla's electric vehicles, especially in motors, battery packs, and the drivetrain. This is a massive advantage, as these components have been tested across millions of kilometers in real-world conditions and extreme climates. Meanwhile, 1X and Unitree are still developing proprietary hardware for each robot line, with limited production scale and no established repair or service ecosystem. This means, if a malfunction occurs, repairs may take longer, or may not even be feasible for regular consumers. Tesla also takes a major step ahead with its over-the-air OTA software updates, allowing the robot to continually improve its efficiency. From refining limb movements to reduce power usage to learning optimized paths around the house to save time, everything contributes to lower energy consumption while increasing task performance. Neither 1X nor G1 Pro has yet demonstrated any intelligent energy optimization system like this. One final and crucial point: Tesla Optimus is currently the only humanoid robot actively used by Tesla in real factory settings. It doesn't just clean, it also carries objects and transports materials across assembly lines, environments that demand high productivity, speed, and extreme durability. This is a real-world test that neither 1X nor Unitree has passed or even attempted publicly. Who's taking the most effective path to bring humanoid robots to the public? Tesla Optimus is currently the fastest developing humanoid robot project on the market. In just 2 years since the first prototype, Tesla has already deployed Optimus Gen 2 for real-world testing in its factories. According to Elon Musk, thousands of Optimus units will be officially rolled out at the Giga Texas factory starting in the fourth quarter of 2025, performing tasks such as material transport, loading, and assembly line assistance. This is a crucial step toward mass production, with a target of 50,000 units per year beginning in 2026 at Tesla's dedicated robot manufacturing facility in Fremont. In terms of team structure, June 2025 marked the departure of Milan Kovac, the head of the Optimus project, after 9 years with the company. However, Tesla swiftly appointed Ashok Ellaswamy, former head of the autopilot team, to lead the project, signaling a stronger integration between Tesla's autonomous driving AI and humanoid robot development. This strategic move allows Tesla to leverage its pre-trained AI infrastructure from its EV network to accelerate robot advancement. On the market side, Tesla is attracting strong interest from logistics companies, manufacturers, and healthcare providers, with hundreds of partnership inquiries for testing Optimus. Elon Musk stated that the most feasible business model could involve leasing or bulk sales, rather than selling units individually. With over-the-air OTA software update capabilities and a massive data ecosystem generated from millions of Tesla vehicles, Optimus is more than just a robot. It's an extension of Tesla's broader AI strategy. This depth of data and rate of improvement is something no current competitor can match. While Tesla bets on production scale and factory integration, Norwegian company 1X Technologies is taking a more cautious path, with its Neo Gamma robot focusing entirely on home environments. This robot is designed for indoor use, with a height of 1.65 meters, soft movements, and a friendly human-like appearance. Unlike Tesla, which targets labor-intensive tasks, 1X aims to create a socially interactive robot, one that can recognize faces, engage in conversation, assist elderly people, and learn user habits over time. Neo Gamma is powered by Redwood AI, a proprietary artificial intelligence system trained per household, allowing the robot to adapt to specific communication styles, commands, and environmental cues in real home settings. Unlike Tesla's generalized cloud-based AI, 1X prioritizes data privacy, with each robot storing data locally and avoiding cloud uploads, a feature that builds trust among home users and families. As of mid-2025, 1X has begun deploying hundreds of Neo Gamma units in homes across Northern Europe and the US, primarily targeting elderly care and gentle social interaction. The company plans to expand to thousands of pilot units by the end of the year, with commercial release expected in 2026. While pricing has yet to be officially announced, analysts estimate that the Neo Gamma will retail between $20,000 and $30,000, depending on configuration and software support packages. In contrast to Tesla and 1X, China's Unitree Robotics is not aiming for the consumer market just yet. Instead, it focuses on the research and development community with its low-cost humanoid platform. The Unitree G1 Pro is currently the most affordable humanoid robot in the world, priced at just around $16,000, yet it boasts impressive technical specs: 23 to 43 actuators, dynamic balance, jumping ability, and high-speed mobility. It's specifically designed for AI research, reinforcement learning, and agile robotic movement. The G1 Pro stands out due to its open-source compatibility, support for ROS robot operating system, and popularity among developers for its customization flexibility. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.